Hello dear students, today we are going to talk about complexity analysis of an algorithm. So before going into the complexity analysis of an algorithm, you have to understand what is an algorithm. Okay, so in the previous classes we have discussed about algorithm. So you know that when there is a problem with you and you have to solve the problem, you have to follow certain steps. Algorithm is nothing, it is step-by-step instructions when followed in sequence gives you a solution. That is what algorithm is. Okay, so in the previous classes we have discussed about the features of algorithm also. So there are mainly 5 features of an algorithm. They are input, that means your algorithm should have 0 or more number of inputs, and output it must produce one output. Okay, and the next feature is that it should be definite. That means you have to write your algorithm in such a way that it should not create any confusion. Definite in the sense it should be clear and unambiguous. Okay, the next feature is finiteness. What is this? This means, as I told you, that this algorithm is a step-by-step instruction. It is a collection of step-by-step instructions, and that means it contains a lot of instructions. Okay, so finiteness means what? The term itself says that your algorithm should contain finite number of steps. That means after certain process it should terminate. Your algorithm should terminate after instructing or after processing or executing certain number of steps. Okay, so that is finiteness. And the last feature of your algorithm should be effectiveness. That means any layman in the sense any person who is not related to the computer science field may also understand what this algorithm is, should understand what this algorithm is. So this should be written in such a way that this algorithm can be executed manually using pen and paper, and also it should be simple enough to be understandable by any other person. Okay, so that any layman can understand this. So these are the 5 features of an algorithm. Okay, so now think about a scenario. Suppose you are sitting in a classroom and your teacher comes and she gives you an assignment. Suppose you are having 30 students, the strength of your class is 30. So that means that she has given you a problem P. One problem is given to you and you are supposed to find the solution for that problem. Now what you will do, all the 30 students will be writing solutions for this problem, and they are not sitting in a group, they are thinking individually. That means that all the 30 brains are working for solving this problem. Okay, and after some time all these 30 students are coming with the solution. That means solution in the sense they are giving the correct answer for this problem. Okay, so when we see that the answer is correct, for this problem the answer is correct, so we can say that okay, this is the solution for that problem. So since 30 solutions, 30 different logics have been applied for solving that problem, now the next concern of the teacher is to determine which algorithm or which logical thinking should be given the best prize, okay, or best gift, or it can be taken as the best thinking, best process. Okay, so that means the teacher has to judge which out of these 30 algorithms which should be taken as the best algorithm. Okay, so that means she is going to do the performance analysis of an algorithm. That means she will be taking each algorithm written by each student and she will be doing performance analysis on that algorithm. So what do you mean by performance analysis? Okay, so this is the most important term related to an algorithm. When you go to any interview, when you go for an interview in future, they are definitely going to ask you what do you mean by performance analysis of an algorithm. Okay, so that means if any algorithm is given to you, you should be able to analyze that algorithm and should conclude whether it is a best one or whether it is a worst one or whether it is an average one algorithm. Okay, so performance analysis of an algorithm is very important topic related to data structures and design and analysis of algorithms. Okay, so this performance analysis of an algorithm, performance analysis of an algorithm. Okay, so this is the topic. So performance analysis of an algorithm. So this performance analysis, so suppose you are going to buy a mobile phone. So when you are going to buy a mobile phone or a laptop, okay, what all factors you are going to consider? Suppose you are going to buy mobile phone, then what all factors you will consider? You will consider the speed, the processor used in that mobile phone. You will consider the camera pixels that are present in the mobile phone so that you can get high quality pictures, okay, and then what, the size of the memory, okay, so that you can store a huge amount of data in the mobile itself, okay. So these are the certain specifications you check before going to buy the mobile phone. And you are not going directly to one particular product and you just buy it. No, you are going to analyze the mobile phone coming from different brands, isn't it? You will definitely do that analysis, and after doing that analysis you come to the conclusion that okay, I will buy this mobile product. So based on certain factors you have analyzed the mobile phones, and then you come to the conclusion, then you came to the conclusion, then okay, I will be going to buy this mobile phone. So similarly, in case of the algorithm, certain factors are there on the basis of which you are going to analyze the performance of an algorithm. Okay, these certain factors are known as this performance analysis. The other term used for this performance analysis is complexity analysis of an algorithm. Okay, so this performance means what? You are going to analyze the complexity of your algorithm. And this complexity analysis of an algorithm is divided into two terms. Okay, so the first one is space complexity. The first one is space complexity, and the second one is time complexity. Okay, so space complexity, and these are the only two factors we focus to determine the performance of an algorithm. So what do you mean by this space complexity? So this space complexity is nothing, it is the memory space used by that algorithm to complete its task. Okay, so the total amount of space, the total amount of memory space needed by that algorithm to complete a specific task, that is known as space complexity. So space complexity, so how you are going to say that this algorithm is best on the factor space? When you think about the space factor, that means when your algorithm is going to take minimum amount of memory, minimum amount of storage space for completing its task, we call it is known as the space complexity of that algorithm. Okay, the minimum amount of the memory space required by any algorithm to complete its task is known as the space complexity. Okay, so this space complexity focuses on the memory space. So this space complexity is nothing, it is focusing on the memory space used by that program. Okay, and next is what? Time complexity. So similarly, this time complexity means what? This the minimum amount of time, the minimum amount of execution time needed by an algorithm to complete its task, that is time complexity. Okay, so total execution time needed by that algorithm, and if that total execution time is minimum, then we can say that the time complexity of that algorithm is the best one. We can say that this algorithm is best one if it is giving you the minimum execution time. Okay, so this time complexity focuses on the time factor. Okay, execution speed, execution or run time. So these are the two important factors based on which you are going to analyze the performance of an algorithm. Okay, so now first we are going to talk about the space complexity. So before going into the depth of the space complexity, you are aware of the fact that when you want to execute your program, that means you are provided with a problem, and you already written the algorithm for that problem, and after writing that algorithm, what you did? Naturally, you are going to convert that algorithm into a programming code using specific programming language. Okay, suppose you have used C programming language. You have converted your algorithm into a programming code, and the language that you have used here is C programming language. Okay, so now what you have to do, so before going to the execution of that program, what is the next step you have to do? You have to load your program into the computer's memory. That is what happening when you are going to save that program in the computer. Okay, so all that is happening internally, and you are not bothering about that. Okay, so that is what happening when you are loading the program into the computer's memory. That means you are going to utilize, your program is going to utilize the memory space of your computer system. Okay, so the program which is going to take the minimum amount of memory space is said to be the best case algorithm or best case program. We can consider that program under the label best case. Okay, and related to the execution or runtime, when your program is executing, the total time required to complete the task, if that total time is minimum, then we can say that we can take or we can consider that algorithm under the label best case. Okay, so we can see all that using some examples. Step by step I will be explaining you the terms space complexity and the time complexity. Okay, so first is the next is the space complexity. So suppose we are having the, suppose we are going to add two numbers. Suppose you have written an algorithm. This is your name of your algorithm, add. Okay, you are going to add two numbers, and what is the result? This result is going to give you the sum of these two numbers. And suppose the numbers, the parameters here are a comma b. Clear? Now this I am not going to follow any specific rules for writing the algorithms here. I am just providing you the logic that you are going to use while writing the algorithm. Okay, don't think that this is the right way of writing an algorithm. Okay, I am just mentioning the logical part here. So add a comma b. So what you are going to do, what this algorithm is going to do, it is just returning the sum. Okay, a plus b. Suppose you are going to have this sum s is there, and it is going to add a plus b, and it is returning s. Okay, this is the only two steps written here in this algorithm. Okay, so that means the two parameters are there, and when you are going to give these two values to these a and b, these a and b will get added, and it is going to be, the result is stored in the s, and you are returning, this algorithm is going to return the sum of these two numbers. And suppose the value s is equals initially 0. So when this algorithm is, you have written this, you have written the algorithm, you have converted this program into C programming language, and when you are executing this C program, that means when you are executing after completing the compilation and everything, when this program is getting executed, what is the first thing coming up on the screen? You will definitely see enter two numbers to add. Okay, so some statements will come, and the meaning will be that you have to provide two values. That means two parameters are there, so you have to definitely provide two values. So you will be giving two values. First you will type one value, then another value. Okay, so suppose you are giving the first value is 5, and this 5 is stored in a memory location. Suppose this is a memory location, and the value 5 is stored here, and we are symbolizing this memory location with the name a. Okay, so this is the concept of variable. When variable, what do you mean by variable? This variable is pointing to a memory location where you are going to store your value. So here the value 5 is inputted by the programmer, by the user. Okay, and this 5 is when inputted, it comes to this memory location, and we symbolize this memory location as a. So definitely we have another memory location, and we are symbolizing that memory location with b, and when the programmer is entering the second number, suppose the second number is 10, so that 10 is stored in this memory cell. Okay, so now these two values are there, and what is the next when this execution happens, what this s equals to 0, that means there is another memory location, and we are symbolizing that memory location with s. and the initial value of S is 0. Okay, now when the execution comes here, when the controller comes here, okay, so what is happening here? A plus B, that means A plus B, 5 plus 10 happens and addition happens, and that answer is stored in S. Okay, so this 0 will be overwritten by the value 15. Clear? So this time once one user came and executed this program with the values 5 and 10. Next time another user comes and execute this program. So again on the screen that message will come, enter the two numbers. So naturally that user will provide two values. Suppose a user is providing two values. Okay, so and the first value is 25 and the second value is 30. So 25 plus 30, it is here what is happening, it is 55. So again you can see that only 3 memory locations are used for the second user. For the first user also 3 memory locations are used. For the second user also 3 memory locations used. Now similarly, do you think that when other users also come and execute this program is going to take more than this number of memory locations or less than this number of memory locations? No, it is going to be same for every execution. Whenever this program is going to be executed by any user, it is going to take only 3 memory locations. We are assuming that for storing the value of A, this program needs one memory location, one memory word of space. For storing the value of B, this requires one memory word of space, and for storing the result S, this is requiring one memory word of space. So total how much memory words are there? There are 3 memory words. So the number of times you are going to execute this program with different values, this program is only going to take 3 memory words. Okay. So now you are going to calculate the space complexity for this program. Space complexity. Okay. This space complexity is indicated by capital S, small p. Sorry, this capital S, within the bracket you have to specify the problem. Okay. S of p. And this S of p is equal to C plus small s and subscript p. Okay, this is the formula for determining the space complexity of any algorithm. So what is this S? Yes, this S is space complexity, and for whose space complexity you are going to determine? You are going to determine the space complexity of this P. Okay, and this C is the constant factor, and this SP is the instance characteristics. So let me tell you what is this instance characteristics. This is a new term and this is the constant part. Okay, clear? This is a new term and this is the constant instance characteristics. So I will tell you what is this instance characteristics. Instance characteristics means at particular moment of time this variable will be having a particular value. Another particular moment of time this variable will have another value. Okay, that means that during different instances of this execution this variable will be having different values. Okay, that comes under the term instance characteristics. Such variables come under the term instance characteristics. I will explain that terms more when I take another example. Okay, so you have to understand only one thing here. When you are writing a program, you are definitely going to use different variables. Okay, different variable names you are going to use for different purposes. So some variables you might have noticed that some variable is going to take only a constant value. That means throughout the execution of that program, that variable will be having the same value. Okay, it is not going to change the value. The variable is going to give you the same value. But some variable, when you are going to execute that program different times, that variable is going to take a different amount of memory locations. Sometime it will take less, sometime it will take large number of memory locations. Okay, so that is what comes instance characteristics. And the memory, the variable which is going to take only a fixed amount of memory space, we call it that comes under the term C, constant part, and the next SP comes under the variable part. Okay, that means the variable which is going to take different amounts of memory spaces during its different execution time. Okay, during its different execution process. Okay, so I will explain to you that term using different example. So let me come back to this example. So you are going to calculate the space complexity for this algorithm. Okay, so what is the name of this problem? P. What is the name of our problem? P. It is add. So you will write like this, S of add. Okay, now you have to fill C part and SP part. So you can see that so constant part means what? The variable when the program is executed, the number of times you are going to execute, this variable, this constant variables will be taking only fixed amount of memory space always. Okay, that comes under the constant part. And what is coming under the SP part? Those variables which are going to take different amounts of memory spaces during its different executions, that variables comes under SP, instance characteristics. Okay, so in this case, do you think we have any variable which comes in SP? The variable we have executed this program twice with different values, and you have noticed that only 3 memory cells are utilized by this program. Okay, nothing more, nothing less. Okay, so that means there is no instance characteristics present in this variable, in this program. Here we have only 3 variables. A is there, B is there, and S is there. And these 3 variables are using only one memory word each during each execution. Okay, so we can say that the 3 memory words. For C we can write 3, and for SP we can write 0. Okay, so we can say that the space complexity of this memory is this program is 3 memory words. That means what? If you want to execute this program, it will require minimum of it will require minimum 3 words, memory words to store to complete its task. Okay, minimum of 3 memory words. So this is what? This is the space complexity of this algorithm. Okay, so when the number of time you are going to execute this program, it is going to take only 3 memory words for completing its task, nothing more than that and nothing less than that. Okay, so hope this is clear to you. Now I will show you another example where you will find instance characteristics. So let me show you that. Okay, suppose we have an algorithm where you are going to add sum of n numbers. So that means you are provided with an array. You are definitely going to add using an array, and the number of elements present in that array, you are going to add all these numbers and you will be getting the sum of that n numbers. Okay, so how you are going to write that? Suppose that is add. Okay, and you will have your array name. A is your array name, and n, small n, gives you the total number of elements present in that array. Okay, so you are starting your program. So sum is equals to, you are having a variable sum which is initialized with 0. Okay, and at the end this sum will have the total summation of all the numbers. Okay, it will give you the correct answer at the end. So definitely you are going to use a for loop, and we are having one I. It is a counter variable used in the for loop. So for I equals to 0, your I should be what? I should be less than n. Okay, I should be less than n. Here is I less than or equal to n, and I plus plus. And you are in the for loop, what you are going to do? You are going to get the sum. Okay, so sum will be sum plus a of I. This is the sum, and after the for loop you are returning this sum. Okay, so here you can see you are having an array A, and this n is going to give you the total number of elements present in that array A. and here this sum variable, it is going to hold the summation of numbers present in that array, which is initialized to 0 at the beginning of that program. Okay, and now you have started one for loop. Why you are going to start a for loop? Because you have to traverse the array so that you can retrieve one element one by one, and you can take that element and you can add that element. Okay, so that is why you are going to use the for loop, and inside the for loop what you have written, sum is equals to sum plus a of I. So you know that what is the meaning of a of I. A of I means what? Initially the I value is 1, so what happens? A of I, a of 1, that means it is pointing to the value which is present in the array index 1. Okay, so that basic concepts are clear to you. So let me explain you this algorithm with an example. Suppose we have an array, and suppose when this program is executed, what happens? When you have converted this program into C programming language, C programming code, and you are going to execute this program, what is coming on the screen first time? It will come, definitely that program will ask the user to enter the total number of elements present in that array, total number of elements that you want to add. Okay, so the user will provide that element. Suppose user has provided n equal to 5. That means the user wants to add 5 numbers. So n equal to 5. So your array will be having 5 locations. Okay, and suppose your array index starts from 1, this is 2, 3, and this is 4, and this is 5. Okay, and so this is your n, total number of elements is 5, and this is your array A. So since a user has provided n equal to 5, so your memory manager, your operating system has allocated 5 memory, you allocated an array with 5 size, with the size of 5. Okay, that means it can hold 5 values. Now your on the screen, what is the step, what is the message will, which message will come? The message comes, enter 5 numbers. So the user will provide 5 numbers. Suppose the user has provided 10, then 20, 30, 40 and 50. These are the values provided by the user. Okay, so what happens? So all these values are now stored in the specific indexes of that array A. So let me start this program. So A is this one, this your array, n is having 5. Now sum value. Okay, so first, before going into the depth, you have to list down what all variables you have used here. How many variables you have used here? We can make a chat variable, space needed for that variable. Okay, so first variable is what is the first variable used here? This is the n. Okay, when you have entered the value of n, this is the variable n, and in this memory location this 5 will come, this is n. So how much space it needed? This n needs only one suppose the space needed by the variable is 1 memory word, the minimum space. Okay, 1 memory word. So this, for storing the value of n, it requires only 1 memory word. So the space required, you can write 1. Next variable which you are seeing here, sum. So for this variable, initially what is the sum value? Initially the sum is initialized as 0. So for storing the value in the sum, it requires 1 memory word. Okay, next variable you can find here is I, the counter variable used for the for loop, for iterating the elements present in that array. Okay, so the next variable is I. So another variable is there, memory cell labeled as I. So initially the I value is 1, then the next iteration I value becomes 2, then 3, likewise. So all these will be overwritten here only. So that means this counter variable I is also using only 1 memory word throughout the execution. Okay, so here also. Now the next variable, what you see here, the A, this is your array name. What you see? How many, what is the size of this array here? How many memory cells are needed for this array A? In this execution, during this execution with the value n equal to 5, this array A requires 5 memory cells. So you can write here as 5 for this particular execution. Okay. That means for completing the task, this array requires 5 memory cells. This is clear? So total how much memory space it is requiring? You have to add all these numbers. So 5 plus 1 6, 6 plus 1 7, 7 plus 1 8. That means total 8